Alright, what we're looking at is a modified version of the disk method that we talked about before. Pretty much what's happening now is instead of revolving around an axis, we now have a different line that we need to revolve around. Pretty much we need to first say, well, where does it intersect that line? So for this case, the line is 1. So when does 1 equal our function, 2 minus x squared? Well, that means if I were to solve this, I would have x squared is equal to 1, which means x will equal the square root of that, which is plus or minus 1. So that's the first part. That means that when we do our integral, we're going to have from -1 to +1 being our intersection points, our limits. The new function, essentially what do I need to do to get this so it would have been around the x-axis? Well, it's raised by 1, so I really need to take this function and subtract 1 from it. So that means my new function, f of x, is now going to be, actually I should call it something different, I'll call it g of x, whatever, is equal to 2 minus x squared minus 1, which is just 1 minus x squared. That's now the function I'm going to use. 1 minus x squared, that whole thing is squared. So volume will equal pi times that dx. Okay? We need to first expand. So pi times, still the integral of -1 to 1 of 1 minus, it'll be 2x squared, and then it'll be plus x to the 4th dx. Okay? Now we want to look and take an antiderivative. So I have pi out front. I'm going to have x. This will be minus 2/3 x cubed, and then plus 1/5 x to the 5th. That's evaluated from -1 to 1. So I need to plug in both 1 and -1. When I plug in 1, I'll have 1 minus 2/3 plus 1/5, and that'll simplify out to be 8 over 15. And then when I plug in -1, it will be the same numbers, but just the opposite sign. -1 plus 2/3 minus 1/5. So I'll get a -8 over 15. So what I need to do is 8/15 minus a -8/15, which will give me as an answer 16 over 15 and multiplied by pi. So 16 pi over 15 as my answer. And that's how we do this modified version of the disk method when we don't have it right on an axis.